Mr. Rops.
And Mrs. Flynn.
And we're going to take you through a linear modeling task, which is what you have to do for your C&D criteria coming up here soon.
And in class, we've already talked about using the measuring.
You're walking away from the sensor with Logger Pro. And so you should have some kind of data that looks like this, right? And so the next thing the task says, copy and paste this data set into Autograph and Excel. Well, let's go to our data set. And
let's find out which produces the best line. And if you're just visually looking at it, maybe we want to pick something
like over in this kind of thing here, I'm almost thinking.
Yeah, so between the time maybe a little bit before 2 seconds to a little bit before 4 seconds.
Right. And the reason why I'm not going to pick this part down here is because this is when I started walking and stuff like that. This is me walking away, and then I had to turn the sensor up. So let's go from 2 to 4. 2 to 4. So if I go to my chart here, I'm going to select 2 and drag it down.
And we're looking at just our time and our position.
Right. I'm going to drag it down to 4 seconds. There we go. Come back.
All right.
Here we go. And I'm just going to copy. Go to Excel.
And
let's put on, I'm going to put time first. I'm going to make a heading. And then I'm going to go over to
distance.
Distance. Okay. And then paste.
Beautiful.
Nice. And so now there is all my data. It's in Excel. I'm going to take it now with the headings. I'm going to copy it and move to that new program called Autograph.
All right, so to add a table, you can just click on this little icon here.
All right.
It's enter the XY.
Right, and so then I just paste. And you'll notice that it's already given me headings.
Nice.
Right, so
make it so easy.
I say OK.
And there it is.
There's our data set. I can go to hand and I can drag it over here a little bit. And I can see. Right, and so here is my data set. I think this is the right zoom box. There we go. Nice, zoomed in. Okay, so we've put it into Excel, we've put it into Autograph. And what's the next task says for us to do? It says
choose 2 points that are reasonably separated and look most like the general line and create an equation. We've been doing that from our last unit.
We have. So let's go over to our data set.
Yeah.
Here is our data. Come here, Autograph. Okay, and so let's pick, I don't know, this point here. Can I pick that point by itself? Oh, I don't think so. I have to go to my table. And, oh, what's going on here? Oh, it wants me to do a new one. If I click on here, okay, and I know it is the point that is about, I don't know, one right here, which is going to be 2.25. I can just estimate that one. So let's pick this one here. 2.25. I wonder if I can cut and paste that. Copy that. And so hang on to it when we put it into Notebook. Can I get it?
Nice.
Oh, nice.
Now let's pick another point that's further away. The further we are, maybe the more accurate. At least we'll get a line that goes through those 2 points.
All right. How about this one right there?
3.5. Somewhere around that.
Okay, so let's go 3.5. Oh, 3.5 is this one. Copy. And then I'm going to paste it again. Oh, and then
there we go.
Okay, super. So now it's just a matter of we have 2 points making our equation.
Well, though we only need 2 things. We need first our slope and second an XY point to write an equation.
Right.
So let's see. I'm going to turn so I'm not writing sideways here.
Okay.
Okay. So y equals mx plus b. To find our slope, ooh, we might need a calculator for this one.
Yes. I found a new trick though.
Oh, you did? Up there. That's right. Okay. So change in our y. So 1.01885 minus
5, 6, 9, 1, 4. All right. And I'm going to divide that by
3.5 minus 2.25. Okay, so using
Oh.
Mr. Rops's
spotlight, we can go
parenthesis.
1.
Can we do the whole thing in
Oh,
parentheses?
we probably could. So parentheses 1.01
8.
885 minus 0.65 6914
All divided by
divided by
3.5.
2.5 minus 2.25.
Enter.
Enter, and we get 0.26.
I should probably write that down here.
Where did I go? Hold on. 0.2895. 0.2895.
0.28.
95.
All right.
Okay, so there's our slope.
Okay, so now we have y equals 0.2895 x plus b.
We just plug in one of our coordinate points.
Which one do you use?
Let's do the 3.5 one.
Okay, so y 885
equals 0.2895
times 3.5 plus b.
B.
Now we can use this again, I guess?
Yep. And so we're going to go 1.01885 minus
parenthesis
0.2895 times 3.5.
enter.
Oh, don't hit enter. It shows me right there.
Okay.
0.0056.
So we know that 5, 6 is b.
So our equation then.
So our final equation is y equals 0.2895x plus 0.0056.
Okay, so now I'm going to go over to autograph. You have to help me remember those numbers.
Oh, geez.
Okay, so here, maybe we'll just make our window so we'll cheat a little bit here. There we
Okay,
go. There
okay.
we go. And so I'm going to cancel that. And if I go to this equation button now, enter the equation, I go y equals 0.2895x plus 0.0056.
Press enter.
Enter.
Wow.
And it goes really nicely through all those points.
Looking good.
Looking very good. Okay.
Well, I wonder how good it really is, though. How
good-
could we measure that?
Well,
Something to think about.
it is something to think about. Let's see what's next on our task here. So we've, using autograph, we've got this line. Super. Then it says create the line of best fit using autograph. Well, that was a pretty good fit, I think, but technology sometimes can come up with a graph as well. And so what I'm going to do is I'm going to select all that set and go object, and I want, I think it's the x on y regression line. And if I look on this one over here, pull over my thing, I should be able to see my, oh, I went
Might
the
be
wrong
better
way.
to
I went
do
the
that.
wrong way. It should be y on x. So
Maybe
let's
just
try
do
that.
undo.
Undo. There we go. So I want, I have to select my points. And I want object y on x. Which one did I do last time?
Yeah, do y and x
Y
this
on
time.
x this time. I like that better. So I get this equation here in red that's coming through there. Y equals 0.289x plus.
Maybe we should just copy that
0.0286.
and
Let's
paste
see.
it and put it, just so we don't forget it.
Good idea. So we're going to copy it. Let's put it onto our notebook file so we can hang on to it. And let's just paste. Here it is here.
So now we have the model that technology gave us and the model that we came up by analytically solving for M and B.
Right. And so, okay, let's go to our task now and see what we have to do. Compare visually the two graphs and discuss. Wow. And let's look at these graphs and see what we see. So some of the things I know is that they both almost have the identical slope.
It's an increasing slope.
It is an increasing slope, positive. They both seem to go through a whole pile of points, so that's really good. They're very similar in many, many ways. The y-intercept, is a little bit different, but they're pretty close. I'm happy with our math.
Yeah.
The computer likes our math too. All right, then it says we can compare them visually. Then using Excel, compare the two graphs numerically. Now, so we just can't say, even looking at this data set, I couldn't tell you which graph is better.
It's hard to tell.
Because they look pretty much the same. So we have to have some kind of good reason to say one's better than the other.
So what can we do mathematically to prove that maybe our model is better or the technology's model is better?
So here's our model. So I know our model, and I'm going to, let me show you the formula bar. So when I view the formula bar as I go, formula builder, there we go. So I'm going to type in equal to, what was our slope that we came up with? Let's put our model in. Let's see if I can sneak it out from the bottom.
So we have y equals, so we're at equals 0.2895 x. Well, our x value actually happens to be in what cell?
Oh, it happens to be time. This one over here, A2 in this case.
And that's an A2. So you can click on A2 or you could type in A2.
I have to make sure I multiply though. Times A2.
And then to that we are going to add
plus 0.0056.
Press enter.
Enter.
The nifty thing about Excel is we could just go ahead and
I could type this in again, equal to.
Well, that takes a long time.
That's going to take
I'm always for shortcuts. Give me a shortcut.
So what you do, you go here, you bring it over to the corner there. See how the cursor changed to a solid black, or to a plus sign? Drag it all the way down to the end of the table.
Fun.
And these are the values that your line has created all the way through.
So using our equation, those would be our y values. Right. So I wonder, from the actual values to our model, what's the difference?
Right? The difference? Well, let's find out. The difference. So, well, I go
Well, difference just means subtract. So we could just...
Let's go...
actual...
minus
our model.
We hit enter. And now let's look at all these.
Yeah, let's drag it down again. Back and forth.
Okay, super.
Why do you think some of them are negative?
Let's talk about that. Let's see if we can draw just a rough sketch of what's going on. Where's it? Okay. So let's see if we can draw a quick rough sketch of this scenario going on here. So I know that I have something like this and a bunch of points here. And I have my line going above them. The calculation we just found out was this value and that value and that value.
So some points are below the graph and some of them are above the graph.
Exactly. And so one of them is positive and one of them is negative, depending upon how we subtracted them. So
if I really want to find what the true difference of those values are.
Right. I don't want the positive and negatives to matter.
No. And by definition, the true difference of a number is absolute value.
Right. So let's go and then take the absolute value of these. So ABS of the difference. And so it's going to equal to, Excel's really smart.
I'll look at over here too, off to the right.
ABS, there we go. ABS of that one. Enter. And so that should be positive, and let's drag it all the way down.
Now we're finding the true distance between the 2 points, between the model and the actual values.
Right. And so now if I just come along here and go the sum of all these, it'll tell me how much all those values added up, which is 0.3106.
Now that doesn't really mean too much to me. What's another way we could look at this?
Ah, yes, we could do percent error. So we could do percent error.
Sometimes it's easier to think about how much am I off by what percent.
Right. So to do percent error, I go equal to, what do I do for percent error?
Take the actual.
Parentheses, the actual, so distance.
Minus my
Model. And then divided by the
actual times it by
times by 100.
100.
Okay. And if I take this now.
I wonder if we should have done this so that it was all positive, but that's okay. Now we're going to get negatives.
We are going to get, let's change our formula then. Let's just so put on.
Since we did the difference already.
All right, let's just make this.
We'll just use that cell.
That cell instead. Oh, so smart. Now we have to drag it down again to replace all the old
It's not changing
values.
to percent for some reason. I wonder if we need to have.
Oh, I think it's just really small error.
Oh.
Yeah, it's just really
Fancy.
small error. We're really good. So
Yeah.
now I can go ahead, I can get the sum of that. I know this is a sum command. I'm going to drag it over, and it's going to give me the
You can
sum.
drag it all different directions.
Right. Okay. Let's pause right here.